All right, everybody. How are we all doing this evening? Man, it came down to the wire to get ready for this. I had to go ahead and change my stream information just like right at the tail end there. Hello, him Jay. Man, it's just been one of those days today, running around like crazy. Had a 4.5 hour long Akhenaten cluster training this morning. Did a whole bunch of little stuff. Reviewed one of our first Akhenaten service discovery plugins we're going to publish. It's all AWS focused. That's looking pretty good. So Gregorius and our team did that. Nelson, good to see you. So did some of that. Went to the gym. And then I've been working on CEO stuff, which mostly involves Excel and PowerPoint. I'm doing a lot of that today too. Always something. So I'm ready to go ahead and actually do some programming for the first time today. And to drink a little bit of bubbly. The music's a little loud, so I'm gonna turn that down just a hair. All right. What I have tonight on the drink docket here is actually not scotch, nor is it bourbon, in fact. Today I have Irish whiskey, Redbreast 12. So this is from a single pot still, and I haven't touched this bottle in about a year, but Irish whiskey is very, very underrated. It's usually, in my opinion, pretty sweet. So the tasting notes on the bottle here say a mix of dried fruit with toasted oak, sherry, and cherry undertones. Dried fruit and spice. So I take it this has been aged in a sherry cask. Let's see. Triple distilled and matured in the finest oak cask. So not necessarily aged in sherry, which a lot of Scotch products are. All right, well, we'll go ahead and pour some of this out. I haven't had Irish whiskey in a little while. This is the first drink I've had since the last stream we did on Thursday. I've been trying to get over a cold, so I lay off the sauce when that happens. Man, I can definitely smell a lot of oak on the nose there. Definitely has a little bit of heat to it compared to American bourbon. Definitely get a bit of dried fruit there. Get a little bit of things like dried apricot, that sort of stuff. Yeah, get a little bit of spice. Tastes pretty good, although I'm getting something kind of musky. Oh, I'm drinking a Redbreast 12. I'll go ahead and type that out in chat. Irish whiskey. Now I gotta say, this could be the glass. Maybe my glass is dirty. I don't think so. These are almost always clean. But this actually smells funky to me, like it's not good. Cork smells fine. Although I'm still so stuffed up, possibly from having had a head cold for the better part of a week, I may not be able to palate it properly. My nose might be messed up. So in that case, I got Diet Coke over here on the right. Yeah, it smells musky, like wine that's been corked, something like that. Yeah, it doesn't taste good. Not tonight, anyway. Although this whiskey is normally very good. I'm assuming either my glass that might have something funky in it, even though we clean all those Glencairn glasses, or maybe my palate is still totally destroyed from being sick. So we'll stick with Diet Coke then in that case. That's all right. Save whiskey for when I can actually smell it and appreciate it properly. All right. Well, I want to talk a little bit about where I left off last time around, which is we were starting to do some actual experimentation on using F# to go ahead and model some of our protocols for Sdkbin. And I've been having some fun with this. And actually, I think I have, if I go ahead and pull this over here, Go ahead and get rid of some of this stuff. That's some of my CEO work. I still have all of our tabs from last time around, all of these F# for fun and profit web pages made by Scott Walshman. So I'll go ahead and drop a link to this in chat today as well. So if you're interested in checking out F#, you can use his website. Now, what I'm trying to work on today is Scott has a really interesting article that is not something that I've really had a lot of luck doing in C#, which is basically, he's got actually a great series on types overall. Let me see if I can find it. Interfaces, designing with types. Here we go. Okay. So there's two things I really want to try to accomplish today. And the things that got me interested in taking a look at this were these posts here. Number 3, making illegal states unrepresentable with the type system. So if we take a look at my other code, let's see, I think I have it. Let me get rid of that. Some stuff from my training today. Here's my original C# code I've been working on. I went ahead and downloaded that branch that I've been working on the previous couple of streams. And I went ahead and I just downloaded that branch as a zip file and stuck it in another location on my development machine here. So I still have all that code sitting in here. Now, one of the things that we had been working on is sort of, I'd say, a pretty standard C# approach for trying to go ahead and validate models and state, which was we had this product state object, this big old record here. And then I had these extension methods designed to go ahead and produce these transitions between functions. And one of the things that we had to do was do a lot of this sort of pre and post condition type junk to go ahead and basically make sure that our product state was in a legal state before we tried to go ahead and do this. And that's why I wrote all these validators and all this sort of stuff. And that's like a pretty tried and true C# approach to addressing these types of problems. No issue there. What kind of got me interested in taking a look at F# in the first place for this, having never really used it in a serious application context, I've actually worked with F# for years, primarily maintaining the build system, which is written in Fake for most of our software. So I've used F# quite a bit in that realm, but I've never really worked with it on an application development point of view. So one of the things that got me interested in taking a look at F# was I'm emulating a lot of very functional patterns inside this code. Namely, we're doing a lot of sort of incremental builder work. We're using records. We're trying to use option types in a bunch of areas. We're trying to use discriminated unions. And it's just kind of, none of it really looks all that safe with how we've implemented it in C#. So I thought to myself, okay, there's a couple of things I would really like to try to accomplish with F# if at all possible. If I could do this with C#, I'd do that. I'd give that a try first. The things I really wanted to try to accomplish is this first one, making illegal states unrepresentable. Imagine for a moment if instead of using, let's say, a library like Fluent Validation, to go ahead and see, am I in the right precondition to process this event? Imagine if instead of having to go ahead and use a bunch of validator classes and waiting for a validation report to come back, imagine if it was simply not possible to express an illegal state with a type system. Well, F#'s algebraic type system might just allow us to do that. That way, rather than this being a runtime problem, it can be a compile time problem, and we can use static analysis to deal with that. So that would be a very worthy trade-off for taking on the learning curve of working with F# in order to go ahead and have a explicitly type-safe way of representing all these object states in our domain. So that's one thing that I was very interested in. The next was this concept down here. Let's see, making state explicit. So the big idea about this is being able to go ahead and model things such as state machines. Here we go. Being able to model state machines explicitly with the type system. In essence, that's exactly what these product objects, these payment objects, these fulfillment objects, and everything else all are. They're here to represent a finite state machine. And basically, We have a couple of states where the product is considered to be non-publishable, such as a state where there's no price plan added, such as a state where the product kind has not been set, such as a state where the publisher has not yet uploaded their first package, and therefore we can't actually fulfill it yet. All that type of stuff. Those are states that basically occur naturally in the expression of our domain. Well, I don't really have a robust way of modeling it with the way I've implemented my C# model. Now, there are some ways you can do that using abstract base classes and builder patterns and a couple of things like that. We actually do that internally in a couple of areas in Akka.net. Just to give you an example, actually. Let me go ahead and close all this. I had some tabs open from the Akka.net project today when I was doing my clustering training. But if I go to actor cell children, I think it is. And this is actually the child container. Here we go. We have this child container where you can add, remove children, etc., etc., etc. Well, we have this concept here of like an empty child container. And I think this is a static. Yeah, this is like a singleton class. And so what happens is the first time you go ahead and you try to add a child to an empty container, we actually go ahead and return a normal child container with this data inside of it. So we're actually switching out the states behind the scenes. And then if we go ahead and shut that actor down, we go ahead and we basically turn, actually, let me go ahead and grab this. If we go ahead and we call the shall die method to go ahead and basically terminate this actor, or actually, I think we're terminating some children. I think at least one child. Yeah, here we go. Then we're going to go ahead and basically return a terminating children actor. And then when the actor completely shuts down, we go ahead and have a terminating children. Actually, wait a minute. Oh, terminated. Sorry, I got that backwards. This means that basically all of the children have been terminated and the actor's been shut down. And this is now basically an empty class. This is an example of sort of state machine transitions being represented in C#. And the kind of key to making all this work is we have these interface methods up here that go ahead and return child containers, and we're swapping out the implementation underneath. So we are implicitly inside our domain. We're implicitly basically kind of transitioning between these objects. That's not something that can be easily discovered via the type system, because all of our actor infrastructure that leverages this is looking at we're looking at the interface. We're not looking at the class implementing it. So we don't necessarily know what the underlying behavior of this is from the outside unless we start trying to downcast it, right? One of the things I really like about this F# approach is rather than making state implicit, which is what we were just talking about, we're trying to make state explicit, where you can go ahead and see exactly what state the state machine is in. And so Scott gives some examples here of state transition diagrams, which is a common way of trying to express how each of these units of work eventually kind of work through their life cycle, given a sequence of events, which may or may not arrive in the same order, of course. But like we have an empty state, we add an item, we're in an active state, we keep adding items, and then we pay, and we're in a paid state. This is exactly the same sort of transitions that we saw with our child container just a moment ago. And you can see some other examples here. Well, if we can go ahead and basically explicitly document our state and allow different behaviors in each of these states, a lot of this precondition and validation stuff that we're all trying to do in C# might be something that could be encapsulated inside the type system. So where I'm kind of going with all this and all this exploration is, look, I'm a practical developer. At the end of the day, if there's anything that kind of rules my philosophy as far as software development goes, it's I want to go ahead and do what is going to get me from point A to point B as inexpensively as possible. But I also want to go ahead and keep in mind, how can I make it inexpensive to naturally evolve and kind of maintain the software over a long period of time. I don't just think about what it takes for me to meet the deadline. I think about what it's going to take for me to meet, all the deadlines that come after that too. So I do tend to think long term, but I'm very practical about how I go about doing that. So it's not really deciding whether to use something like C# or F# isn't a matter of, it's not necessarily a matter of preference to me. It's a matter of practicality. I've sort of been on the wagon for years of acknowledging some of the F# strengths in this area, but I've never allowed myself to actually sit down and properly learn and try it because my reasoning has always been, I live in a C-sharp world. All the things I do on Akka.net every day are primarily C-sharp oriented problems. And I also like being able to have fine-grained control over things like how, mutable classes are evolved and things like that inside C-sharp, which is a little bit easier to do than an F-sharp here. Well, I have a different problem with Sdkbin. I'm not necessarily concerned about performance in Sdkbin because I'll put it this way. If my biggest problem is that I'm getting so many people trying to buy products in Sdkbin that our CPU gets too busy, that's a fantastic problem to have. I promise I'll be able to afford to fix that problem when it happens. The problem I can't afford to fix is if we have a whole bunch of foot guns littered throughout this sort of state system, and I have another software developer who inherits some of my code and succeeds in being able to go ahead and introduce dangerous or legal or non-backwards compatible changes to our code that ends up creating massive fuck-ups in production. That's really kind of like the bottom line for me with this application, is because we're working with our customers' access to products and services we depend on, and we're working with our customers' money, we cannot tolerate fuck-ups, basically, is the goal behind it. So being able to use the type system to go ahead and make it impossible at compile time to screw something up in one of these ways is really attractive to me from that point of view, because it means basically the feedback loop between when a developer wants to introduce a change and when they get told by the compiler, or really get told by the software you can't do that. A compilation error is about the shortest path between a developer introducing that change and being told no that I can possibly have. I want that. I don't want the developer to find that out because an integration test failed inside our test suite somewhere. And by the way, maybe that integration test doesn't fail because they introduced a new complex use case that we didn't capture because we can't exhaustively test everything in an integration test suite if there's real I/O involved. By the way, with F#, one of the things you can do really easily is introduce model-based testing, which does allow you to go ahead and exhaustively test inputs and outputs. I've written a couple blog posts on how to use FSCheck, which is their model-based testing library. Those are available up on my blog, and we'll probably introduce some of that a little bit later tonight if we are successful where we're going. But that's kind of where I'm at, is I want to make it so developers who inherit the code that is written here do not get the option to foot gun it or blow it in any sort of way. They basically are left with a type system that makes it really hard to go ahead and flub that. That's what I really want. And so I am starting to believe that F# will allow me to accomplish that very goal. And that is worth a lot of money to me. So we are going to go ahead and give this a try. So let's start by taking a look at how state machines might be implemented in F#. That would be a good place for us to begin. Although, what code do I still need to write here in order to kind of get back to where I can begin really writing this protocol? Let's see. I built my change log. I even tested a little bit of it yesterday. That was pretty cool. Built my change log. I added my I with user ID types. Added my result classes. Added my product types. Added support for interfaces. I did some of this offline. And I added all of my display types here. Let's see. Let me go ahead and do this. I'll go ahead and do M of markdown text, H of HTML text, and P of plain text. There we go. All right, that should work. Let me go ahead and do a triple comment line like this is how you get XML comments for F#. So I go ahead and mouse over this. I see my comments are to show up now. That's a little difference between F# and some of the other standards we use for C#. Let's see. Let me go ahead and try building everything. So I think I was having some trouble Namespace utilities is not defined. Okay, if I try opening just utilities.collections, that won't work. Namespace utilities is not. Namespace. Did I spell it wrong? I don't think so. Module collections. That all looks right to me. Open users. Open Sdkbin.common. All this stuff appears to work. Sdkbin common abstractions on display. Open. All right. Okay. Stack is not defined. IntelliSense tells me that it is, but stack T data of list. Stack data of T list. Well, in order for me to go ahead and create a stack, if I go ahead and uncomment that, change log entry, stack data. So this is sort of an implicit type at the moment here. Then this type gets assigned when I go ahead and do this. Okay. Go ahead and do E. Push changelog entry log. All right. Let's go ahead and give that a try. Value or constructor of stack data is not defined. There's still something this damn thing is really unhappy about with opening this namespace. I can't figure out for the life of me what it is. Let's see. All right, let's take a look. F#. Namespace is not defined. Why might that be? Let's see. I wonder if there's a thing I need to do to use a namespace. Let's take a look. Finding a namespace. Let's see. How do I go ahead and do use? I'm Googling off screen here. Use a namespace. All right, Microsoft. Lay it on me. Namespace widgets, type widgets module. Namespace global, recursive namespaces. Top level modules. Bottom was first declare a namespace. Okay. So let's take a look at this. I don't know why that's there. All right, let's delete that. So I have my namespace, sdkbin.common.utilities. And I have a collections module. This looks pretty standard. Module users, right. Collections, right, that looks fine. Namespace, sdkbin.common.abstractions. All right. I wonder if my problem is because of how I'm defining some methods here. Let's see. Change log. I had a feeling that wouldn't work. Instead of using a module to hold your value declarations. Okay. Maybe this is part of my problem. All right, let's go ahead and build this. So modules can also contain functions and things like that. They're basically like little static classes. Sdkbin, common, utilities. All right. Okay. It seems to want to be able to open that. Let's just take a look here. I had a feeling. Okay. That explains why that wasn't working. Man, I basically added and removed this project. I gotta go ahead and reload this. That's what's going on there, is writer's state is dirty. Tisk tisk. Okay, let's get that open again. Oh man, what a waste of time. Okay. Well, that definitely seems like a writer bug. But basically, I added a product reference, I then removed it, and then I tried to add it back and it wouldn't let me without reloading. Hopefully that'll fix my issue. All right. Okay, we're in business. Fantastic. All right, let me go ahead and go to Sdkbin common. Fixed compilation issue. See if I can finally get the build server to be happy with me for once. I'll go ahead and enter my pin in here. All right, there we go. So by the way, I had another big Sdkbin thing I had to do yesterday. We had to upgrade the minor version of Kubernetes in our cluster. Before July 31st, we got an email from Azure saying they were killing off support for Kubernetes 1.18. So I had to go ahead and upgrade us to 1.19 yesterday. And this is the version where they dropped support for Docker shim and all that stuff. Turns out Docker containers still run fine, so it wasn't as scary as it sounded. You just can't use things like Docker within Docker anymore on Kubernetes in that environment, which is fine with me because we never did in the first place. We always built our Docker images on Azure DevOps. Okay, this is looking good. All right, yeah. And I'll go ahead and do let test log equals extend. See if that worked. Perfect. So this, by the way, is how I go ahead and turn this into this discriminated union, like that. If I do let empty log equals empty, that will also work. Perfect. This is all the implicit casting system that F# uses. All right, well, that makes me happy. Okay, so change logs are good to go. Let's see. This is my Pulumi stuff. Let me get rid of that. That's all good to go. What else do I need to actually do my job here? Let's see, user identity. Yeah, I probably need to do some user identity stuff. Okay. All right, so I probably need to do a little bit of that. So I'll go ahead and stick this into, where's my change log? I with user ID. Yes, we'll go ahead and do that. We'll do user ID. We'll do name, ring, then we'll do user email. string. We'll go ahead and just memorize all that into that little user source right there. All right, and then I need to go ahead and add another new project. Well, how's everyone else doing tonight? I'm pretty happy to not be doing trainings again tomorrow. My voice could definitely use the break, but I always like actually doing the trainings. It's just afterwards I always feel pretty like I've run a marathon. Let's see. Yeah, I think I need to delete all those folders. But how's everyone else doing tonight? Let's see. I guess it should be Sdkbin. Yep, let's go ahead and do that. Add reference. Sounds good. And then for my users abstractions, we'll go ahead and do a little module here. Call this and we'll go ahead and call this right here. And we'll go ahead and define both some functions and some types. So I already have in here this I with user ID type, so we're going to reuse that. We'll go ahead and do a type user identity. And then let's see, I think I already had something. Go ahead and implement the I with product ID type somewhere in here. Yeah, here we go. This is how you go ahead and implement an interface. Oh, hey Matt, good to see you, man. We're repping your product here, doing some F# stuff. All right. Okay, this nope, Irish whiskey still smells musky. I'm gonna have to try it some other time. All right, type user identity equals, and we'll go ahead and do name, ring, email, string. In fact, you know what? There's something else we can do that'd be pretty fun, which is Scott Walshin's got an entire post. And I'll go ahead and do, I guess this, yeah, I'll do user ID. And then, let's see, what type is this actually? User ID of string. Okay. You need someone else around you who's being productive. You came to the wrong place. No, we do our best. We do our best here. Okay. Let's go ahead and do open sdkbin.common.abstractions. All right. Let's see. I think I need to do that. There we go. All right, we got our interface implementation. Oops. Not mean to do that. Represents a user's standalone identity Sdkbin independently from any organization to which they may belong. All right, that looks good. We got that. Got our identity going. Let's see, what else do we need to do? Got my I with user ID type. Man, it was on the tip of my tongue. Oh yeah, I wanted to go ahead and add and use the F# type system to actually validate some of these strings. And lo and behold, Scott's got a great post on that. I'm going to be repping Scott's stuff for quite a while here. All right, let's go ahead and grab that post. Because you know what? I prefer to use the type system to do this stuff rather than having to rather than having to use things like fluent validation if I can help it. Okay, here we go. Designing with types, constrained strings, adding more semantic information to a primitive type. So we can go ahead and basically perform some types of constraints on these domain types if we want. So for instance, we can go ahead and validate that an email is a valid email address, for instance, right? This sort of stuff. So basically what Scott's trying to get at with these sorts of posts is you're used to writing validation code like this. The way you handle this at runtime can be somewhat kludgy. You'd usually just throw an exception and abort the operation. But what if it wasn't possible to have this type of error because the type system would not let you? Wouldn't let you do it in the first place. Well, that is an interesting idea. Tell me more, Scott. Well, he creates some examples down here where he creates a module of string 100 where the string has a length of 100 in here, and it performs, of course, some null checks and some length checks. And in the event that, let's say, the string does not support any of these requirements, we use option types in F# to go ahead and essentially return a no option, a none, which means that there's no value there. None is like a more type-safe way of doing essentially like nulls and that sort of stuff. So, all right, I'm intrigued so far. And then he mentions a couple of better ways of doing this. There's ways of doing this without any duplicated code. I'm like, all right, I'm all about that. And then he mentions at this point we can exploit F# support for interfaces and create a common interface that all wrap strings have to support, and also some standard functions. All right. So we have a standard interface here that basically supports this value method that's going to go ahead and return a string. All right, got it. We're going to go ahead and create a wrapped value option. We have to canonicalize the input first. If validation succeeds, return some of whatever's in the constructor. If validation fails, return none. Null values are never valid. Okay, that seems pretty good to me. So create canonicalize is valid ctool. Well, this is a bit of I think this is monadic sort of wrapping here, where these are all individual functions that are being passed into this parent function right here. And the idea being, I suppose, that we're going to go ahead and pass in our own implementation for canonicalization and our own validation implementation here and our own constructor. All right, makes sense. Apply the given function to the wrapped value. Apply s wrapped string. This is basically a hint to the function that we're creating as to what our input type is going to be. So F# primarily uses implicit typing. We're making this explicit here because sometimes the implicit typing system isn't quite robust enough. Then we're going to go ahead and get the wrapped value, do some equality test, equals left and right, and do compare to. All right, that seems simple enough. So with this in place, it's a lot easier for us to define new types. Okay, so it looks like they're creating a validation function here that's going to canonicalize the string and replace any trailing white space at the end of the string. So that's like a sort of standardization function. We're going to go ahead and add a little length validator. All right, looks good. And then we're going to go ahead and just define our type. And we're going to go ahead and say, all right, this is a string 100 of string with interface wrap string. Member this.value equals let. And this is our constructor, is this in S. And then, let's see. A constructor, so this is the constructor for this type in here. So we're actually implementing some of those type methods that were defined earlier. All right. And so this converts, oh, oops. I accidentally unplugged my headphones here. Which is one of the hazards of having cables right around the wheels of your chair. In here. Oh. Wouldn't be a stream without some production mishaps for me. At least this time we don't have OBS freaking the fuck out and blowing us up with notifications, which is what happened the other night. Oh yeah, no, you can still hear me because my microphone is safely decoupled from my headset here. This headset's actually been having some noise quality issues, so I've had to have my big boom mic sitting over here off to my left. Okay, long story short, I'm on board with the idea of using wrap strings and this sort of stuff and getting in the practice of doing that sooner rather than later. I'm on board for that. Okay. So we create a wrap string. We go ahead and define some types that we can go ahead and work with. Blah-de-da. For example, here are some helpers to work with map. Map contains key, map, blah, 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 blah. Using new string types in the domain. Here we go. Module, personal name, open, wrap string. Type, first name, string 50, last name, string 100. Create a new value. All right, so we're going to go ahead, pass all this stuff in. All right, I'm on board with this. Semantically, I like the idea of the type system being responsible for going and representing all this stuff. But you know what? Maybe I can go ahead and introduce this to my model a little bit later. Maybe it's more, rather than getting all excited about string validation, using the type system for that, which feels frankly like a little bit of small potatoes, even though it is neat. I would probably rather focus on building these state machines. Let's go ahead and do that. We'll go ahead and skip the string validation stuff. So I've got my user identity type here. This looks good. And then I'll go ahead and create a little function here. Let me go ahead and open sdkbin.common.abstractions.changelog. I'm going to go ahead and make a little method here. Let's see here. I got to go ahead and give this thing a name, I guess. What function was this I was looking at earlier? Here we go. Yeah, all right. That looks good. So we're going to say let changelog user. And then I think, let's see, where's my little stat class? This stat class I built with a lot of help when I was looking up how to build data structures in F# online. Push X, stack data. Okay. Gotcha. X is an arbitrary type. We're going to go ahead and add those together. Got it. Okay. To change log, we'll go ahead and call this user identity. I'll go ahead and provide a little type hint here. Equals, and we'll go ahead and do, let's see. I'll go ahead and do a U. User identity. Try to turn this into a changelog source. Let's see. Actually, let me go ahead and grab. Let me go ahead and use multiple tabs here. Let's grab my changelog, put that on the left. All right, so I need a changelog source first. So I need to go ahead and say, all right, I need to create changelog source. Let's see, we'll go ahead and say user identity. Hey, man, I'm such a baby when it comes to this stuff. Just so new to doing all of it. All right. I just need you to give me the power of F#, people. Okay. I think this is still right. Okay. I need user identity.user ID. Ah, that's right. To actually go ahead and create an instance, I got to do this. identity. Then we've got name, user identity. And then we've got user email equals user identity email. Okay, and there we go. This will go ahead and return. Converts a user identity into a change log source. We're going to use this inside our change tracking system. All right, that looks good. Let's go ahead and see if that all compiles. Let's see if GitHub is happy with us. First time I've gotten a green check mark on the F# version. Very good. Nicely done, Aaron. Let's see. Okay. Next, I've got, let's see. Next thing I need to add in my little user protocol here is we're going to go ahead and create a new module. And we'll go ahead and call this user protocol. User activity protocol. There we go. That's what we called it in C#. User activity protocol. All right. So we'll go ahead and call this namespace Sdkbin.users.abstractions module. Oops, spelled that wrong. User activity protocol equals this. And now you decide you don't like Sdkbin? Stupid. Resharper, or sorry, writer. All right. So first thing I'm going to go ahead and do is create. So this is the C# type I'm going to try to recreate here. A user change event, which is basically a wrapper around another underlying event internally. So I have my interface, this iUser activity event here. You know what I should probably do is I should probably change my approach a little bit for how I'm going to merge all this stuff together. So I'm going to go ahead and do a type user activity record equals. I'm going to go ahead and have identity. Actually, I got to open a module here. Let's go ahead and do open user identity. We go to identity, user identity. We're going to go ahead and have a, I'll go ahead and declare a type for this up in utilities. We'll go ahead and add a new type. We'll go ahead and call these, let's say, type strings, I guess. You know what? I'm not going to go that nuts just yet. I can always add this later. We'll just go ahead and do a string for now. So I'll go ahead and add an IP address. If people are messing with buildable methods and all that sort of stuff, someone's got to know. And then I'll also go ahead and add, let's see, date time offset. Well, actually, I'll go ahead and call this a timestamp. Date time offset. And then I'll go ahead and say interface I with user ID. And then I think the way I implement this again, yeah. This dot user ID equals this dot identity user ID. I think that's right. Member. Oh, I forgot the with keyword. Okay. Let's see. Common data included with all user activities are logged by Sdkbin. All right, now I got to define type user activity event. And then I need to make this generic. So I'll go ahead and I guess declare it as such. T. And we'll go ahead and say, yeah, this should be good actually. Yeah, that makes perfect sense to me. All right, we'll go ahead and say this is in here. Go ahead and have say activity record. And then we'll go ahead and have the. All right, there we go. Generic wrapper for activity events. Now, if I want to make a marker interface, which I'm going to need for serialization, I guess I can just add that later. That's probably not the end of the world. So this looks okay. So let me go ahead and commit all this. Let's see. Flushed out user activity protocol. Go ahead and commit that. Move that over here. All right, push that up. Okay, that's looking good. Now we can get to hopefully the real stuff. I think I need to add back my organization stuff. Let's go ahead and do that while I'm here too. Let's see. Did I add the concept of a navigation name to my display module? Yes, I did. Okay. Yeah, okay. I guess this should be okay. Go ahead and add a new module here. Organizations. Yep. Whoops. Yes. Space. Module organizations. We'll go ahead and do a new interface. I'm basically go ahead and copy what we did for users. Organization ID string. Yep. Okay, I with organization ID. And I'm going to do abstract. That looks good. All right. That looks good. You know what? Let me get a load of this too. Activity record should have all this stuff though. Should it not? Huh. All right, well, guess that should all be in place there. Okay. That looks good. Let me go ahead and add my organizations project. We're almost back to where we were with the C# code. All right, Sdkbin dot organization or organizations dot directives. Go ahead and add all that. All right, and then I'm gonna go ahead and name this we'll go ahead and derive from Sdkbin.com without abstractions. Namespace. We'll go ahead and call this module publishers. Okay. We'll go ahead and do type. We'll go ahead and say publisher data. And this is going to go ahead and have a, now let me go ahead and open this also. Sdkbin common organizations. That's good. Actually, I turned the sensitivity up on my mouse. It's one of the downsides of having a good video gaming mouse. Let's see here. Any reason why your modules are in plural? Plural denotes collections. No, not really. Like, I basically have some stuff like products, users, organizations. Yeah, I don't really have a good reason for naming it that way. It's just kind of arbitrary. Yeah, I haven't really given it much thought to be on that. That's the subject, to be honest. Yeah, I'm just thinking out loud. In terms of, let's say, I guess, domain areas, I tend to just kind of think of that as like, this is something that's going to be partitioned into lots of different individual actors. And I just kind of naturally kind of gravitate towards having like pluralizing all that. Whereas something like a change log, which is really just kind of like a simple standalone data structure, or display, which are just kind of standalone data structures there. I've got no problem giving that kind of a singular name. So yeah, it's just, I don't have a good answer for you, Nelson. No idea. Let's see. Yeah, no worries. I got you. Let's see. I also want open Sdkbin.com and instructions display. I want my navigation name. You know what? It's a better way of doing this. Type. Organization data. And then, actually, let me do this. An organization can be either, though. But publishers are required to have some extra information. Publisher data. I'm just going to go ahead and copy this rather than try to get cute. Okay, and then both of these should have my little interface. I'll eventually be able to remember how to do this. I just got to build up my muscle memory first. I with organization ID. can do that in both places. Type organization data equals customer of customer data. No, don't need that. Oh wait, I gotta define this after I've defined both of these child types. Equals publisher data. For now, organizations can only be a publisher or a customer in a given context. All right, there we go. That looks good to me. Now we really do have everything that we need. Let's go to products to abstractions. Actually, you know what? I want to go ahead and work on my concrete product definitions. All right, Sdkbin. Sdkbin dot product dot domain. All right. Add a reference to Sdkbin.products.abstractions. Let me go ahead and rename this. There's going to be some protocol classes, by the way, that we introduce later into some of these libraries. I'm not just kind of doing this willy-nilly. I just haven't really gone through and denoted all the different little ones yet. So a couple ways I can go about doing this is I can work on the create new product command. Oh, there is one other thing I'm missing, which is I need to have the fulfillment stuff all stubbed out somewhere. Let's see. Where did we do that originally? Products to abstractions. Yeah, here we go. We had a bunch of different little entities defined. Product kinds and price plans. All right, let's go ahead and do that. So we'll go ahead and add a directory. Well, actually, I guess I don't necessarily need to do this. Modules kind of help quite a bit organize all this stuff. Kinds. Yeah. I had a big dinner tonight, but man, I'm still hungry. I'm totally gonna go and get something to eat after this. My mother-in-law made a big traditional Southern dinner tonight, and it was very, very good. And I wolfed it up right after I got back from the gym. But man, I'm still hungry. Okay. So these product kinds, by the way, are supposed to kind of represent basically like a NuGet product. You might have a NPM product, all this sort of stuff. So this is another example of something I think the F# type system can support really well. Let's go ahead and let's go ahead and take a look at maybe some of Scott's algebraic type representation here. Representing states. Let's go ahead and say make illegal states unrepresentable. And so the way they came up with this was email only, post only, email and post, which is where you have a combination of both of these. Okay. Excuse me. All right. So here's what I'm going to do. I'm going to go ahead and say type package manager products. Actually, I guess there's a couple ways I could do this. Fulfillment kinds. All right. So I need to have a couple of abstract little properties that every single product kind should have. So let me go ahead and declare a little interface. Yeah, I'll do it this way. So, oh, what's this grumbling about? Maybe it's because I haven't committed that one yet. Type I product kind. And we'll go ahead and say this product kind is going to go ahead and have a description. Abstract. I can go ahead and add. I can add some of this stuff later. A logo. A stored file. Move that into here. A description, a logo. And then I guess I should go ahead and have, I don't know. I have some way of representing this in the file system. You know what? Don't overthink it. We can always go ahead and add that stuff later. Type, let's go ahead and say actually no, I guess we really should have some of that. And so then go ahead and have type NuGet product equals, let's see, description string You know, I don't really want to deal with the logo stuff just yet. We'll add it later, maybe. Description string. And go ahead and do interface iProduct kind with member all right, that looks fine. Represents a NuGet product for our system. I'm gonna go ahead and create another type of product. We'll go ahead and say support plan product equals although, you know what? I kind of want this. Well, I don't necessarily want it to be. I kind of want those just to be like sort of singleton types almost, is what I'm really trying to represent. We don't need a huge amount of information on the type bits and pieces here. Yeah. I think there's an F# none type. Or null or void type. Let's see. What's the best way to do F# singleton? Of course, the first thing I take a look at when I want to figure out how to do a singleton in F# is like they're talking about lazy loading. Let's see. All right. Product instance.do something. Okay, so I guess we declare a member. Type product private constructor. Okay. Let's give that a shot. Type NuGet product. Move that over on the left. I think it's called unit. Yeah, I think you're right, Nelson. I think that's right. But I basically, here's what I'm trying to really do is create a bit of a singleton here. So let's go ahead and do that. Type NuGet product. I don't necessarily need this iProduct kind stuff right now. Is that right? Type product private. All right, and then I'll go ahead and do static let instance equal static member. All right. Oh, member's got to be lowercase. Works. All right. Cool. Okay, that's what I wanted to. All right. And then if I have a support plan product, you know, basically we're just trying to we're not trying to necessarily specify the parameters for how this product gets fulfilled necessarily. What we're trying, that's actually going to be handled via a totally separate set of mechanisms. What we're trying to basically do is tell the fulfillment system, listen, here's the type of product we want to dish up. Go ahead and generate the fulfillment request for us. And we'll go ahead and get an email and a whole workflow related to that. Let's go ahead and do this for support plan product as well. Right. I'll go ahead and do both of these. We'll go ahead and do new support plan product. All right, that looks pretty swell. Represents a support plan product sold to a user. All right, now I can do my fun little union types. Type package manager product equals NuGet of NuGet product. So if I added ever a new package, let's say a new type, let's say we added support for NPM packages. I can go ahead and do NPM of type NPM product eventually. I can expand the discriminated union. Let's see, next I can go ahead and do type service product equals, there's multiple service products we might want to add support for in Sdkbin. So we've got support plans, which are probably going to be the most common one. Well, I'd want people to be able to sell things like a consulting package or a training package too, eventually, at some point. Even though, you know, we like recurring revenue, it's also good to be able to go ahead and support one-off products as well. Support plan. And then we'll go ahead and say type product kind equals package of package manager product. Service of service product. There we go. So now I have a way of going and representing product kinds as basically one of these different little states down here. Represents any supported package manager product. Represents any supported service block inside Sdkbin. And you know what? I'm gonna go ahead and add another method a little bit later. Represents any supported plugin. I'm gonna go ahead and add a little method. Let create let's see. Declared this declaration element is not permitted in augmentation. I wonder if I need to use a fun keyword in here. I don't think so. Let's take a look. Yeah, I don't think so. I think I'm okay. Match P with this declaration element is not permitted in augmentation. All right. I guess because I'm not using the member syntax. Let match P HP with all right, I can do that. What does this want me to do? I wonder if my pattern match is messed up here. I think it is. Okay, let's take a look. Match email opt with some email. Yeah. Maybe that's the better way to do it. All right. Let me go ahead and get rid of that. All right, let's give this a try with some NuGet product and F# matching on types. This is my problem. Okay. Touche. Okay, so I've got to provide a little type hint here as to what I'm actually trying to do. Let's go ahead and say P package manager product. Match P with okay, come on. Maybe a marker interface is the way to go here. I just got rid of them, but let's give that a shot. Okay. All right, let's go ahead and give this a shot. Type I product kind equals interface. Okay. And so then down here, I'll go ahead and do interface I product kind. Yeah, it should be okay. And why is that not working? Do I need to do this? Okay, that works. I can get on board with that. We'll go ahead and say new get product. Pattern in discriminator is not defined. Okay, let's go ahead and try this. That doesn't look like it's working. Let's see. I guess I think I need to do with interface. With interface. Misspelled pattern name. Let's see. F# pattern match on interface. Identifier patterns. Yep. Okay. Is this how I do it? NuGet product A. Boy, I feel like a babe in the woods with this stuff. What am I doing wrong here? Yeah. A switch statement in C# would let me do some of this. So there's got to be something I'm missing here. Yeah, what am I missing? Let's see. Basically, what I fundamentally want to be able to do is just represent one of these types as a product kind here. So let's go ahead and do a simpler test. Let A equals NuGet product.instance. And we'll go ahead and call this NuGet. This makes it a package manager product, and we'll call it package manager. I think is the type here. This is basically what I want to accomplish with my function, is I want to be able to do this, which turns it all into a product kind. And so if I go ahead and do E match A, let's see. Incomplete pattern matches. So maybe I'm just not smart enough to get some of this algebraic stuff figured out here. There's got to be a way to do this. This is part of maybe the mind-bending exercise for me. Let me go ahead and commit some of this work. I'm not going to give up. I can see the light at the end of the tunnel here. And I'm sure there's some things I'm doing that aren't idiomatic F sharp. Okay. All right. Let's go ahead. If I go down to my product abstractions, go ahead and add some references to users and organizations. There's got to be a way to pattern match on this product kind thing, too. We'll figure it out. Okay. Let's go ahead and rename this product state. Okay. Now, go ahead and open Sdkbin dot. Actually, damn, there's another mod, another type of model I forgot to add here. We need to go ahead and add price plan. Actually, I should just go ahead and rename this. Edit, rename. Let's just go ahead and call this prices. Change that. Namespace. All right. And let me go ahead and grab. I've got even more stuff. Yikes. All right, now this will be a good instance here. We're trying to make it so we can't represent illegal states. So I'll give you an example. We can't have non-negative numbers for representing our intervals or our price. So let's go ahead and inside utilities, let's go ahead and add, let's say, validated numbers. Well, I guess I'll just call this structure. namespace. All right. Let's go ahead and grab Scott's article on the semantic types with strings. So his approach is to go ahead and do wrapped string in its own little module. And to go ahead and make it abstract, all right? So here's what I'll do. Move this over to the left. We'll move writer over to the right. Grab that. There we go. This is what I was looking for. We're gonna go ahead and do module. In fact, I'll rename this later. Wrapped integer. We'll go ahead and do type wrapped integer. Abstract value int. Interface that all validated integer types will support. I'll go ahead and do create non-equalize. I guess you don't really need to canonicalize an integer. All right. We would say if it's valid. We'll go ahead and say, let's see, I. Then some ctor I. Else none. Create a wrapped integer option. Okay. Let apply f. Go to integer equals s I dot value. I have no idea what that does. I think it just, okay, it just applies a function. All right. Fair enough. We're trying to apply the given function wrap value. All right, we'll go ahead and give that a shot. I have to suspend disbelief for a moment here. Equals apply IDS. The hell? The identity function. I didn't even know that existed. Okay. All right. I guess ID is the equivalent of get hash code or something. You know what? I'm going to rename this I. Just because I want to be consistent. All right. Let's equals left right equals value left. This is the value nope, this is the value property on this class. We're calling this method down here in order to perform an equality comparison. And then we're going to perform a value-based comparison that compare to left, right. Value left, that compare to. All right. This looks good. Single line trimmed, length validator. And this is where we actually start going and creating some types. Okay. Let's go ahead and do a real basic one. We'll go ahead and do down here. Go ahead and do it. Let's see. Let's non-zero. Zero. Well, let me do this. We'll go ahead and say, yeah, we'll go ahead and do non-negative validator. Let's say return I is less than 0. Type non-negative. Actually, let's call this positive integer. Equals positive integer of int with interface I kept integer with member this dot value equals let positive integer I this in I have no goddamn idea what this does. What the hell does that do? I have no idea. Okay. Man, I have no idea. All right. And then let's see, we need to create a constructor for this stuff. I don't know if he indented this properly. Did he? Yeah. I see. Okay. Then we just got to create a little one-liner down here. Okay, maybe he didn't indent this properly. All right, all right. I shouldn't be so quick to jump. Okay, let's positive integer create. Go back up here. Create non-negative validator. And we'll go ahead and call this okay. Okay. Looks good to me. Looks really good. Now I'll go ahead and create a second one. Let's non-zero integer. Ah, you know what? There we go. That should work. Copy this. Give this a shot. All right, there we go. Got a couple structured types here for working with integers. Looks good to me. I can go ahead and close that. Now, if we go back to my little pricing data here, I'm going to go ahead and create a type, billing interval. Let's see, month, year. There we go. This is basically how we do an enum. Yeah, you got that. Then we have type, usage type. Two different ways of billing users. We have license, which is flat rates, and then metered. Okay. Then we have type. I'll just change that to usage. Let's see. All right. Looks good so far. These are all basically just little enums. Hey, Rook. The F-sharp's going okay. We just did a whole bunch of weird stuff a second ago where I basically kind of followed one of Scott Walshin's posts and came up with a whole bunch of typed integers that have to obey certain business rules. So we'll see how well that works. I'm pretty confident it should go okay, actually. So we've got basically some non-negative integers and things like that we're kind of putting together here. And I'm really working on trying to go ahead and create a price plan object. And so these price plans can have recurring structures, and in some cases they don't. So let's see. This price plan should have, I take a look here. So let's go ahead and create one of these. Type. We'll go ahead and call this, you know what? I actually don't need this, I don't think. Domain modeling fade functional. I've got that book, actually. I've got a copy of it somewhere around here. I think I haven't been able to keep track of it since I moved. And the same Scott Walshin, the same guy whose website we've been using, wrote it. And that is a good book. So you know what? You've inspired me. I'm going to go track that down later today and see if I can find it. I'm going to go ahead and track that down. I'm definitely going to track something else to eat down. I am hungry today. But yes, that is a fantastic book. Scott Walshin just does good stuff, you know? All right. So if I've got my old C# objects here, we have a price plan ID, a product ID, a nickname, a recurring structure, which is optional. And then we have a no recurring structure, this sort of stuff here. That's exactly what I'm trying to do, Rook, which is representing domain elements and algebraic types. That area is totally new to me. Never done it before. So before I get too deep into the weeds of some of these state machines and bits I'm trying to work on, I should take your advice and go and take a look at that book again. So I'll go hunting for it in about 15 minutes once our stream's over for the evening. But yeah, I agree. I'm really enjoying representing some of these more complex types of domain objects using these sort of F# union types and that sort of thing. I think I could see the potential in doing this. So yeah, I'm becoming a believer quickly. All right. So price plan that is for one-time billing is always licensed, never metered, I believe. Yeah, a non-recurring structure is not metered. Yeah, non-recurring structure is not metered. And yeah, it's basically fixed price. Okay. The type, we'll go ahead and do, let's see, one-time plan. And that'll go ahead and be, we'll go ahead and make a record type here. And this will have, let's see, I should probably go ahead and create a couple of other objects here. Type, currency, data, I guess. Let's see, what data do we always need to have? Price data. Let's see. Oh! We need to have a currency, and I can go ahead and represent that as a string for now, but that's another instance where I could go ahead and do a more structured type. So we'll go ahead and do currency as a string. We'll go ahead and do unit price as a decimal. Maybe I don't need to do semicolons there. Unit price is a decimal. What else do I need? Price data active. Cool. Actually, now I can go ahead and make that. Basically, this is the data that should be there for all price plans. So yeah, I'll go ahead and keep sticking this on here. We'll go ahead and do type price plan ID equals plan ID of string. We'll go ahead and do a nickname string. Down to custom. I see. Used internally. Okay, we've got a unit price. I should probably go ahead and make a custom decimal too. Yeah, I can do that. We just did that a second ago, but I should go ahead and make that a non-zero decimal. So let me go ahead and add a use custom type to represent non-zero decimal. All right, that looks pretty solid to me. The one-time plan is going to have price data. And then I think that's it. We just have the price data. There's no recurring stuff. So yeah, all right. Then we'll go ahead and do type recurring plan equals. We have the price data again, but we also have a, let's see. We also need to go ahead and create, yeah, a recurring structure, which is going to include, let's see, a interval counts. Which is going to go ahead and be greater than 0 integer. This is using our new type from earlier. So I'll go ahead and do open sdkbin.common.utilities.wrapped integer. Boom, greater than 0 integer, using the type system to go ahead and enforce that. Let's see, interval count. Billing interval, then usage type. I should just call this a usage type. All right, usage type. All right, and then my type price plan equals one-time plan, recurring plan. Represents the price of, yeah, represents a plan a customer can use to purchase a product. All right, that looks good. Okay, we've got product kind all set up. A couple of other little abstractions I need to add here. Kinds, prices. Let's see. Go ahead and add one called product data. And we'll go ahead and create a basically type publish status equals raft published, nope, or archive. I got to go ahead and copy some of my comments from C# here, just so I don't have to repeat any of that work. That's awesome. Man, F# growing on me. All right, let's go ahead and space that out. Build all that. Everything looks pretty happy so far. Go ahead and commit that. Oh, wunderbar. Wunderbar. Here we go. Let's go ahead and push that up. All right, there you go. That's looking good. Type product terms equals, and we'll go ahead and do display text. Actually, I think I'm just gonna do a yeah, this is fine for now. Actually, you know what? No, it's not. That's more like it. Okay. That looks good to me. I should probably go ahead and add a validator for display text. So I'll go ahead and make it to do on here. Okay, I'll make a note of that. What else do I need? Well, this is my complicated looking piece of product display data here. So what's a good way for me to be able to partially build this object up? Maybe I don't necessarily need to. Maybe I don't necessarily need to go ahead and organize stuff this way, the way I was doing in C#. I want to go ahead and try to model. Let's say look at, as our last little exercise for the evening, let's take a look at Scott's post on state machines. That's really kind of where we're going. How to implement a state machine. We have a shopping cart, an active cart, then a paid cart. And that active cart contains active cart data. Okay. So that's how we can go ahead and transition through this. Okay. Note that empty cart has no state data and no special type is needed. All right. Match cart with empty cart. Create new active cart. Paid cart, ignore. Design event handling functions. Event handling functions should always accept and return the entire state machine. That makes sense. If we're working with immutable data structures, that's really the only sensible way to do it. Working with raw states. Print one, payment. Using explicit states to replace Boolean flags. Maybe that's another thing we should do, is have an active price plan and an inactive price plan. That's another way we can go about doing this. Let's see. Unverified data. Verified data plus the time it was verified. Hey, Rook, this is tuple syntax, right? It means that we have an email address on the left and date time on the right. Is that what this is used for? Well, I hope he's still in chat. But yeah, I think that's what that's for. I think it's tuple syntax for going and putting both of those together. Unverified state. All right, well, this is starting to click for me, I think. So what I'm going to go ahead and do between now and the next stream is I'm going to go ahead and find that book, the Domain Modeling Made Functional, and try to apply it to what we are doing here with Sdkbin. So everyone, thank you again for a great stream tonight. I really appreciate it. This was a lot of fun. Thank you for putting up with my experiments in F#. I really enjoy getting a chance to learn some new things. And I'll see you all again on Tuesday. Between now and then, please have a great weekend. And thank you very much again for joining me on the stream. I always have a really great time. All right. Take care, everybody, and have a good night. Nelson, you have a good weekend too, pal.